Chanda Prescod-Weinstein is the first Black woman to hold a faculty position in theoretical cosmology. And in her fascinating new book, she writes about her love of Star Trek, particle physics, and why science is for everyone. The book is called The Disordered Cosmos, A Journey into Dark Matter, Spacetime, and Dreams Deferred. Chanda Prescod-Weinstein is assistant professor of physics and astronomy and a core faculty member in women's and gender studies at the University of New Hampshire. And she joins us now from the New Hampshire Seacoast. Hello, doctor.
Hi, how are you?
I'm good. It's so nice to meet you. Well, to see you again. You were on the show, I think 2 summers ago, and you were talking about this book. And can I just say, this book is so well written, and I have a little bit of professional jealousy. Not only are you brilliant, but you are such a fantastic writer. So I'm a little jealous, but congratulations.
Thank you so much.
You write in the book that I'm also a scientist who, as a child, terrorized her single mother by persistently questioning everything. In what ways did you question everything?
I think like most children, I was curious about how the world works. So I was curious about why things moved the way that they did. I was also curious about why I had to do my chores when my mom said I had to. I was curious about why I was noticing that my teachers treated students differently based sometimes on what seemed to be like racial boundaries. So all of those things to me were really like the same question in some sense, like why is the world the way that it is?
So, in a sense, you were kind of primed to be a scientist from a very young age.
Yeah, I think so. I mean, I think that kids are little scientists. I think that it's a very human activity to be curious about how things work. And so I think that I like probably like most children was very primed to be interested in these questions of how things are, why they are, and maybe I had a little bit of an added layer to it, which is that I was also really excited about math. And so when you connect those two things together, you do head in the direction of something that looks like professional science.
And your mom, too, was very supportive. You dedicate a chapter to her. Looking back, what role did that play in where you are today?
The reason that there's a chapter to my mother in the book, and it's in the form of a letter to my mother, is I wanted to acknowledge the work that my mom had done and the way that her work is a contribution to science through me. And that was as much, part of it is I wrote that chapter. I didn't tell my mom about it until right before I had to make a decision about taking anything out of the book. There were no other choices that could be made after a certain time. And I wanted to thank her, but I also wanted to acknowledge in a very political way that the work that people do, the caring work, raising children, doing housework, is in fact work that has to be acknowledged as such and that it contributes to science.
And you, in the book, that, I love science, but my mind, I don't know, maybe I didn't have the right beginning, but there's so much joy in this book. You encourage people to ask questions. And you also write, I used to think physics was just physics separate from people. I thought we could talk about particles without talking about people. I was wrong. How were you wrong? And when did you realize that you were wrong?
I think I started to understand it subconsciously before I really started to understand it consciously. And I think that this is an important, part of the journey that so many of us go through in science as we're trying to figure out the experiences that we are having. So I was starting to experience racism and sexism when I was in college, and I had some inkling that those were the phenomena that I was experiencing, but I didn't have a good sense of how to situate them in context. I didn't understand that they were very much embedded in the professional environment that I was seeking to enter. And that this wasn't just a matter of, I was at Harvard for undergrad, that this wasn't something that was just specific to Harvard, even though Harvard has its own kind of version of it that might be distinct in some ways. So, it took me really like a decade, I think, from when I started undergrad until I was really like, okay, this is a structural problem that I can see, that I can describe. And part of it was I had to seek out, I had to learn how to describe it. I had to find a vocabulary for it.
So what changed?
I think a big thing was spending time starting to study the data about Black people in physics and Black women in physics and women in physics in general. Looking at the statistics, I was starting to ask questions about why the numbers were the way that they were. And I was led on that part because I was looking at the classrooms that I was in, and I was not seeing people that I might expect to be there based on the demographics of the community that I'm from and the communities that I was living in. And so I was looking at those statistics and I was reading research about it, and I was starting to see these conversations about structural patriarchy, about racism, about structural racism, about white supremacy. And I was raised by political activists. And so these things were part of my vocabulary already, but I hadn't understood them in conversation with science. And I think what changed was starting to draw those connections in conversation with science.
I want to read something else that you write in the book. Though I work at the intersection of astrophysics and particle physics, it is particle physics that continues to teach me over and over again that the universe is always more bizarre, more wonderfully queer than we think. What is it about particle physics that is so fascinating?
At base, I think I'm always going to be a theoretical physicist who's driven by a fascination with connecting math with the universe. Like the fact that we can use math as this language, we can write down equations that will tell us how the universe works. And by that, I really mean we can write down equations that supposedly describe something that we call quarks and get out a number that we can then actually go to like the Large Hadron Collider or Fermi Lab, and we can actually like measure that number and the numbers match up very nicely. That's incredible. So I think that that's always going to be a fascination for me. And then I think one of the interesting things is that I'm talking to you about the standard model of particle physics, which is often celebrated as complete and an incredible triumph of human understanding of the physical world. And it is. We know a lot about the standard model of particle physics, but it continues to be the case, actually, that we still don't always know how to calculate, even when we have the right equations. We don't always know how to solve them. And so, we still have debates raging in the particle physics community about aspects of the standard model. And that's always fun, and the answers are always, I think, unexpected. It's such an unexpected line of research, and that's really exciting.
And correct me if I'm wrong, but you also say that the standard model is incomplete because it doesn't include dark matter.
Yes. So, again, the standard model is hailed as this incredible triumph. But when we look at, if we're just accounting for matter in the universe, the standard model, which describes everything that we can see. So if you're sitting in front of a window like I am, and there are trees right outside in front of me, the trees, us, planets, stars, we're all made of everything that's described in the standard model, but that's only 20% of the matter in the universe. The rest of the matter in the universe is something that we've come to call dark matter. And then if we think even more broadly about matter energy content, then actually the standard model stuff is only about 4 or 5% of the matter energy in the universe. And so actually, like, the stuff that we're made of is abnormal and we're unusual.
Well, more on dark matter in just a moment. But could you explain what scientists mean when they say space-time isn't straight but curved?
Yeah. So one of the lessons of Einstein's relativity is that we can't think of the three spatial dimensions that we live in and the time dimension that we deal with as separate. So we have to think of space-time together. And it's sometimes useful to think about this in terms of a fabric. So if you think about space-time very simply as like a blanket, for example, that when you put something on a blanket, like if you take like a globe, for example, that the blanket will not stay flat, but it will actually curve, right? It will have kind of a divot, a little well in the bottom. And so similarly, when you have a massive object like the sun, for example, or the earth, it causes space-time to curve around it. And so actually, space-time isn't straight, but there's curvature, and what we call gravity is actually that curvature.
There's so much we don't know about the universe, and it's so great to have you on the show to talk about this. I want to read another passage from your book. The problem with dark matter is that we've never seen it, and there's no room in the standard model, which is built around what we have seen, for something we've never seen. Dark matter also has a public relations problem because it's got a bad name, literally. You mentioned what dark matter is, but why does it have a bad name?
Yeah, so the reason that we think dark matter is out there, right? So this dark matter is in some ways it's a problem because we look at galaxies, for example, we look at how fast stars are orbiting the centers of their galaxies, and they're moving faster than they should be if we're just accounting for the gravitational pull of the stars in the galaxy. And that suggests to us that there's a lot of other matter in the galaxy. So this is what we call dark matter, or the dark matter problem. The reason that calling it dark matter is actually not a great name for it is that what we're dealing with is something that's invisible or transparent. So light goes right through it. So you don't expect, it doesn't have a color to it. It's not actually dark. It's not absorbing light. The light is going right through it. So it should really be called like invisible matter, or P.J. Peebles, the recent Nobel laureate in cosmology, calls it subluminal matter in his recent book. I liked that. I thought that was good. It's maybe sounds a little more confusing for people. So maybe invisible matter is still better for PR.
From the PR problem. You mentioned someone by the name of Vera Rubin. Who is she, and what role does she play in your life?
The late Vera Rubin was in the late 1960s and early 1960s, along with Kent Ford, the person who first found substantive evidence for the existence of dark matter. So she was really the first astronomer to say, let's go look at the speeds of the stars and see what's happening, and realize that the speeds of the stars suggested that there was some invisible matter out there. So Vera Rubin is a very important figure in the history of cosmology because this was a really critical discovery that changed the direction of the field. And in 2009, I met her at a conference for women in astronomy. And one of the first things she said to me was, "How do you think we solve the dark matter problem?" I was completely unprepared for this question, but I think also because of it, I started to think, oh, I'm someone who should have answers to this question. And at the time, as a graduate student, you often don't think of yourself as someone who can solve big problems in physics. And Vera had, there was no like, oh, you're not important enough for me to talk to or for me to ask big questions of. Hey, you're a scientist. What do you think? And that was a very simple and important moment. Hey, you're a scientist.
Was it safe to say that it was an empowering moment?
Yeah, and of course, like in the moment, you're not sitting there going, oh, this is like the most empowering moment of my life or something like that, right? You're just sitting there going, oh, I think actually like I was kind of embarrassed about it because I thought that I should have an answer to the question. And I felt like I hadn't done my homework to prepare to talk with Vera Rubin, partly because I didn't realize I was going to be talking to Vera Rubin. So I was a little bit starstruck. But I do think that it planted the seed for me that this was a question that I was entitled to have an opinion about. And I don't think until that moment I had realized I was entitled to have an opinion about it. And I think that that was really the thing that later, when I had the opportunity to work on a problem relating to dark matter, that I was like, oh, yes, I am entitled to think about this and take ownership over this and try my hand at it.
I want to show you a sketch that you include in the book, and it's by artist Shaniqua Gay. Why was it important for you to include the sketch in your book?
Yeah, before I talk about it, you in the audience won't be able to see it very well, but I just want to say that the painting is directly behind me. The painting is something that I commissioned from Shaniqua. So I should say, first of all, Shaniqua is an incredibly talented Atlanta-based artist, and I was a huge fan. And so when I got my faculty position at the University of New Hampshire, I really wanted to commission something from her. And in part, I wanted to have something in my office that acknowledged that even though I was a barrier breaker as a first in my field as a Black woman, that Black women who came before me, including enslaved Black women, were scientific thinkers, were people who were curious about the universe. And so I commissioned this painting from Shaniqua, and I just said, do you think that you could paint enslaved Black women doing science, like unnamed enslaved Black women doing science, because so much is missing from the historical record? And that sketch is what she sent me.
I often think of the genius and talent we've lost as a society because of bigotry and prejudice. A few summers ago, I spoke to the author Essie Adujian, who has written about this, and this is what she had to say.
We like to think of science as being colorblind, and it's all about, it's a process of experimentation, and and whether you're getting it's sort of in a laboratory, and it doesn't really matter what the scientist's gender or race is, but that I think if you feel like you're working against the current, and you feel like you're encountering great prejudice, that this is something where psychologically you can come to feel as though you don't belong, and this can limit what you're capable of, and then we lose so much of what that potential could have given us.
You write about some of the challenges that you've gone through to get to where you are now. Is this something that you think about, the genius we've lost as societies, as many societies around the world, because of the barriers that the systems we live in have built?
I think a really important point that comes out in the comments that Essie was making in that fantastic clip is really about the attack on our own sense of dignity as human beings, like our ability to see ourselves as thinkers and to be welcomed into the community as thinkers. And so, yes, of course, there are losses to science. I think that that's undeniable. But I think at the end of the day, that's not actually how I want to frame my presence or the absence of people like me or even people unlike me. At the end of the day, the doing of science, I think, is a very human impulse. We like to tell stories. As the Black woman philosopher Sylvia Wynter has said, we are a storytelling species. And science is part of how we tell stories. So from my point of view, excluding and marginalizing people in science is actually about denying people our humanity. And at the end of the day, I want all of us to be able to experience ourselves and understand ourselves in relation to our community as fully human, just like everyone else. So I'm thinking a lot about our personal loss of our sense of humanity and dignity, and not as much about the loss to science, although I do think that that's a consequence of dehumanizing people by taking them out of what fully makes them human.
Just to follow up on what you just said, because you point out that access to physics is often ignored and should be seen as a human right. Is that to add on to what you just said?
Yes, again, we are storytellers as a species. And for some of us, what we like to do is we like to tell stories with math and with the standard model of particle physics, or with Einstein's equation from general relativity. And when we are marginalized away from that, when we experience ableism and transphobia and sexism and racism, including, the addition of colorism on top of the structural racism that some of us face, we are being dehumanized, and we are being denied a part of our most basic human impulses. And I think that that's a really important thing to pay attention to. I want to get away from articulating Black people or Indigenous people as an economic resource for the nation, and think more about what does it mean to allow people to live in good relations with each other and with dignity.
And in the book, you write about freedom. At one point, you write that your idea of freedom was inclusion. What does freedom look like for you now?
As I write in my letter, to my mother, I feel most at home with a Lagrangian, which is a tool that we use. It's an equation that we use. It pops up pretty much everywhere in physics and every field of physics. So for me, it's being able to have a moment to actually sit down and calculate, to think about Lagrangians, to think about how physics works. And, I think that in a broader sense, there are going to be different people who have different versions of that for themselves. I think that thinking about creating the freedom for someone to be able to just sit and think about a Lagrangian and not worry about police shootings, about carding, about being harassed, about being assaulted by the police or by their professor, as it may be, that all of these things need to change in order to give people the freedom to really just sit and think and wonder and understand, or try and understand, our location in the universe, which is an amazing thing.
Would you say that academia is a place that is conducive to freedom?
I think that we are all living in a society that deals with structural white supremacy, with structural patriarchy, transphobia, ableism. All of these things are working together, and academia doesn't exist outside of those structures. And so I don't know if there is a professional environment under our current capitalist society that is conducive to freedom. But I think that regardless of where we are, we can all be doing work to work towards freedom. And I do think that there are some workplaces that are more conducive than others. And I'm in the sense that, at least in academia, I feel like I have the freedom to even come to TVO and have this conversation with you about the critiques that I make. Whereas, for example, there are certain corporate environments where it would actually be my job to try and, keep people from talking about these sorts of things. And so I am glad that in academia, we do continue to have some modicum of academic freedom, even though I think right now, particularly in the United States, academic freedom is really being attacked by people who claim to be for free speech, but are actually very anti-free speech.
You write about the physics of melanin. What is that?
Yeah, this chapter, I think, is the chapter, I'll be honest with you and say it's the one that I struggled with the most, even though actually I thought it was going to be the easiest chapter for me to write because it's based on an essay that I had already published. But for me,
why did you struggle with it?
I struggled with it partly because the more that I wrote it, the more I realized there was to write about it. And I almost feel like, each section of that chapter could actually be its own chapter by itself. I was trying to grapple with, how do we think about race and what is race? And at the same time, I was also very interested in melanin as a biomolecule that has like these really incredible physical features. And the challenge that we face in society, and therefore is reflected in the book, is that those two narratives and ways of thinking about melanin had to be held at the same time. And that's actually a really challenging thing to do, because there is incredible beauty that I'm talking about, but I'm also talking about some of the worst things that have happened in human history.
What can the physics of melanin tell us about the historical priorities of science?
Yes, I think that one thing that's very interesting about, even asking the question, what is the physics of melanin, is that I was pretty far into my career before I started to wonder about this. And you would think that, for all the talk about interesting children in science and interesting Black children in science, that we would want to say, well, here is the way in which like your body is this very interesting thing that exists in the universe. And the fact that we don't have that conversation, that we're not constantly talking to children about how amazing melanin is, really says something about structural racism, about structural white supremacy, and also about the way that colorism operates in service of white supremacy. And this was something that I really had to think about as a light-skinned woman, that I have not gone through the experience that my darker skin can have, of being told that their skin is ugly, right? But I think that this all comes together in ignoring melanin at best, and then the ways that we talk about melanin are completely social. We don't talk about this incredible biomolecule, that all of the messaging really says that, this is not something that's interesting and we should ignore it.
Well, what can the scientific community do to make science more accessible and equitable?
One of the stories that we like to tell ourselves in academia is that the problem with getting marginalized people, visible minorities, et cetera, interested in science is that they're not getting exposed to it when they're in elementary school and middle school and high school. But actually the data shows that marginalized students, particularly from underrepresented racialized minority backgrounds, at least here in the United States, come into university with the same levels of interest in science, technology, engineering, and mathematics as their white peers do. And something happens during the first year of university that leads to them choosing to major in something else. And that suggests that the problem isn't exposure, the problem is the environment, that something in the university environment is not working right. So I think like step one is acknowledging that we have a problem and that we can't just blame K through 12 teachers for everything. I think people like to blame K through 12 teachers for a lot of things that are actually not their responsibility.
I have one more a paragraph to read from your book. Though I've read about patriarchy in books, it is my own experience as a Black woman and an agender person that allows me particular insight into how the total system of patriarchy works. I tend to think of why in terms of my favorite popular science fiction universe, Star Trek. What did Star Trek teach you about the patriarchy?
So in that section of the book, I talk about an episode of Star Trek, of the show Enterprise, where Sato, who is in charge of language for the Enterprise, she ends up being out of quantum phase with the rest of the ship and spends a lot of the episode trying to get people's attention and not being able to get people's attention, but also getting perspective on the lives that her crewmates are living, because she's kind of wandering through the ship and seeing these very personal moments. And it's really, in some sense, it's a thought experiment about what it is to be an outsider and the insight that being an outsider gives you. And I think, I also quote someone in that chapter, I believe, is talking about being a gender dropout and how I kind of identify with being a gender dropout. And I think that being a gender dropout does give you some perspective on how is gender working, because you're watching everybody else who has these strong senses of gender identity that I don't have as an agender person. You're watching everybody else try and negotiate patriarchy in relation to their sense of gender. And I don't have that same experience with it. So I think it's really, as Alice Walker talks about, the loneliness of the outsider can also be productive and useful.
Chanda, I wish we had more time to talk. It's been so great having you on the show again. Congratulations on a phenomenal book. Thank you so much for your time.
The Agenda in the Summer with Nam Kiwanuka is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.